Unit 1, Lesson 3, Data Types. The objectives of this lesson are to write programs with variables of the int, double, and char or car data types. You should understand the importance of matching inputs to the correct data type. In Java, it's very important to tell the computer what kind of input you're going to give it, so it knows how to deal with the data. This means variables in Java are always assigned a type, which tells Java two things. First, what are the possible values that can be stored? This is called a domain, and it's important as Java needs to know how big a box or bag in memory to allocate for the input. The second thing it tells Java is what operations can be performed on the data. For example, can two variables of this type be added together numerically, or are they concatenated as a string? Very, very important. Now, these are some of the primitive data types used by Java. Int. This is used for storing an integer value. Ints are pretty small in memory. And ints are exactly what we talk about as integers in math. They are the negative and positive values that do not have any fractional portion. Char, char, different people pronounce this differently. This is used for storing a single character. Char is the smallest data type. When they are stored, they are represented by a binary code, which comes from the ASCII table. For example, capital A is 65 and lowercase a is 97. Notice that characters are case sensitive. A double. Doubles are used for storing a decimal value, a number which is not an integer. Doubles take up more space than ints because of the decimal component. String. String is also a data type, but it is a class data type. Strings take up lots of space in memory because they have to store each individual character separately. We use strings for anything we won't do calculations with, things like a street address. Now, here's a summary of the information about what types of data you can store using Java. In Java, you can have something called a byte. The range of values a byte stores is -128 to 127. Short, -32,768 to 32,767. Int. This, without going through, there's 2,147,483,648. That's a negative to the other. Okay, long, float, double, char or char, Boolean, and string. Notice 4 of them are highlighted in yellow. The 4 that are highlighted in yellow are the only ones that are tested on the AP exam. This does not mean that within programs and functions that you won't see some of the others, but you won't be specifically tested on those types. So notice I have the values, the types of values here. AP exam will only test int, will only test on double, will only test on Boolean and string. These Boolean and string and character, these are all specialty variables. Character in particular has thousands of characters, glyphs, and symbols. You won't be tested on those, but characters are used to make up strings, so you can't just totally ignore them. Okay, float, that just takes up less space than a double. A double allows you more memory. A long, again, that's just an integer that can take up more space than an int. Now, declaring, introducing. Okay, when you declare a variable, you introduce it to your program. You say, this is the type and this is what I'm going to call it. It defines a space in memory, but does not hold any value. So if we wanted an age, typically we would declare an age as an int. Unless you're very young, you usually don't say you're 16 and a half. You would say you're 16 or you're 17. Your height. Now height, that could be a double, okay? Because oftentimes we're not just 5 feet, 6 feet, we're 5 feet, 3 inches, 5 feet, 7.5 inches. So you might use inches or centimeters, and you might want to use a double, okay? When we talk about a name, that is something that we would definitely use a string for. Assigning. Now, all of three of these, all we've done with these first three is declared these variables. We haven't given them a value. We've just said, we got a box over here, and we're going to put this kind of data value in it. Assigning variables, that's given a value to a variable. So I can say age is set to 17. We've got to be careful with equals. The equals is an assignment operator. So this assigns the value 17 to age. Int can only hold integers. Height, 70.5. 70.5 inches is what I would assume. Okay, double can hold integers or decimals. A double, if you declare something as a double, if I just put in 70, it would store it as 70.0. It would know that there's nothing yet in the decimal portion, but it could put stuff there. Strings need to have quotes around them, like Alice, Bob, Kendra. You would have to put double quotes around those, okay? The double quotes themselves are not stored. The double quotes say this is a string. Declaring and assigning variables. Sometimes, if I know what the initial value of something is, I can declare it and assign it its initial value all in one step. Okay, when you do this all on one line, it's called initialization. So number of siblings. You cannot have partial siblings. They are a sibling or they are not. So int, and then number of siblings is set to. Notice the camel form of the variable starts with a lowercase, but the word of and the word siblings is capitalized. Number of siblings is very clear. I know exactly what that 3 represents. Interest rate. Interest rates are not always, we don't just go by 4% or 5%. You can have 2.5%, etc. So we would use a double, declare it as an interest rate, and give it its initial value, in this case, 3.5. My dog name. We usually give our dogs real names, so this would be a string. And Mila, Goldie, Salem, Bob, Blue, Callie, any of those dog names, you would put the dog name in double quotes. Now, multiple declarations and or assignments. You can declare a bunch of variables and assign them values all in one line. You could also, when you separate them by a comma, you could put them all on one line, or I could put a line return and just line them up vertically. Typically for me, I would line them up vertically so it's very easy to find them. They don't get lost in basically one whole big long line. But you can have multiple declarations and or assignments in one line. I could simply declare x1 and then declare y1 and give it an initial value. You don't have to give them all values. The list of variables declared are separated by a comma. These variables can be just declared or declared and initialized. And again, you could put them on different lines. You could put comma, do a new line feed. The computer, when it's looking at your program, sees white space as nothing. Now, if we want to do calculations, we need number input. To take number values as input from the scanner, we need a different command. So scanner, scan. Notice that scan can be called anything. It's just what I'm going to call my scanner. Is set to new scanner system.in. When a declaration and assignment happens on one line, it is called initialization. So I have declared and initialized my scanner. Int x is set to scan.nextInt. I'm going to go out to scan, which I have declared as a scanner, and it's going to get the next integer that was input from the keyboard. You can do this on one line or on two. It does not matter. So I could do double Y is set to scan dot next double, or I could declare double Y and then say that Y is set to scan dot next double. It doesn't matter which way, you're going to wind up with the same thing. So if you know you're going to pull it from the keyboard, you could declare it and initialize it all in one. Now, we use these commands and then input a string. If we use these commands and we input a string using double quotes, we will get input mismatch exception, which is a runtime error. That means that the code's going to compile and say, you're good to go. But when you run it and you input double quotes Bob, it's going to crash because we told the scanner to look for an int in the terms of X, and for Y we said look for a double, but instead we typed in a string. Your computer's going to crash. It doesn't understand what you're giving it. In general, you'll get this error if you give the scanner a bigger data type than it asks for. Okay, so if you look at this, this will cause an error because an int is smaller than a double. I declare int X is set to scan.nextInt, and I type in 43.2. It's going to have a problem because it can't fit 43.2 into an integer box. The next line there, double Y is set to scan.nextDouble, and I input 6. Not a problem. This will not cause an error because a double is bigger than an int, and it's just going to store it and say, I'm assuming this is 6.0. The third line there, int Z is set to scan.nextInt, and I enter dog. This will cause an error because the types are mismatched. Down here is a little picture for those of you that are more visually oriented. Double is this nice big blue box. Integer is this little purple box. I can't squash something. If I put something in the double box, it could take up this whole box. I can't squash it into the integer box. I can, however, put the entire integer box, okay, the whole integer box can fit inside the double box. The other way around is not possible. Because the boxes used for primitive data types are fixed size, it means there are limits to what they can store, even when using the right type of variable. To access the largest and smallest int values which can be stored, you can use the commands integer.maxValue and integer.minValue. Notice max value and min value are all caps, and they're separated by an underscore instead of using that camel form. Note, the character data type does not appear on the AP exam, but it is very useful to know. The primitive data types tested on the AP exam, again, are int, double, and a third type called Boolean, which you will meet later. These data types let you calculate with all arithmetic operations as well as Boolean operators, which will be explored later as well. We have now arrived at the end of Lesson 3.